Hi, everybody. Good morning. It is morning here now. I don't know what time it is when you're looking. Very early. The sun's not up yet, and I did this on purpose. So I'm sorry that this video looks kind of a little spooky, but I need the dark to help show some stuff about classification of matter. Sorry. All right, to show you a couple of things that come up in the reading for this week that you might not be able to see on your own. But actually, you can try it yourself for a lot of these things. Okay, now you're going to find out that matter, anything that has mass, or if it's here on Earth or any place else with significant gravity, weight, and volume, which means it takes up space, is matter. All right, matter is different from energy. Those are the two things the universe is made of, and we're talking about matter. All right, matter comes in two categories: pure substances and mixtures. And what you're probably going to find is, if you look around and think about it, is there are a lot of mixtures in your environment, your ecosystem. Okay, now pure substances come in a couple of categories: elements and compounds. Elements are like copper here. Okay, just one thing. All of this shiny brownish orangish surface is just a whole lot of single copper atoms. Okay, just atoms. So there's only one word in the name: copper. Okay. The other type of pure substance is a compound, like this one. Okay, baking soda. The only thing that's in here is something called sodium bicarbonate. The name has two words in it. There's more than one type of atom in here. There's sodium, hydrogen, carbon, and oxygen put together. That makes a compound. But all of these little pieces of baking soda, I don't know if you can see them, but you've seen baking soda before. That's all that's in there, molecules of sodium bicarbonate. Okay? So that's it for pure substances. Now we have mixtures. Mixtures come in a couple of different types: homogeneous and heterogeneous. And yes, that word is pronounced homogeneous, not homogeneous. Homogeneous. When you see it written, you'll see there is that E in the middle there that people keep dropping. All right? So, homogeneous mixtures look the same all the way through. You can't tell the parts apart. Okay? And often if something's mixed in with a solution, or okay, and this is homogeneous. If you look at it, it all looks green. Green liquid. Okay? It's called a solution. You can't tell what's been put in to the mixture and what the other part of the mixture is. All right? A solution has two parts: the solvent and the solute. Like, for example, salt water. Water is the solvent. There's more water. Okay? You put salt in, mix it up. Salt is the solute. Now the water tastes salty. All of the salt is still there. It hasn't changed. And if you let it sit, the water will evaporate eventually. The salt will still stay in your container. Okay? And it's still salt, even though you can't see the salt anymore after you stir it in. Okay? Homogeneous means the same thing all the way through. Heterogeneous means different thing all the way through. Hetero means different wherever you see it. Okay? So heterogeneous mixtures, you can tell the parts from each other, and they don't ever mix back up the same way. Like this stuff is called, here's some spices. It's a spice mixture. Yep, you see some black, you see some brown sesame seeds, black salt, black pepper, white salt, there's brownish garlic. And mix it up. You can still, they're rearranged now, but you can still tell the pieces apart, right? All right. Another type of heterogeneous mixture is something called a suspension that will separate into layers, okay, of different things. Okay, here's something called garlic expression, salad dressing, and marinade. You can't really see in there because there's a label, but the cap tells you to shake vigorously before you pour it out. The reason you have to do that is to mix it all up. Once you mix it all up, it's some of the parts are harder to tell apart from each other, but eventually it will settle into layers and you will be able to tell them apart. A lot of things that you can buy in any type of store that tell you to shake before using are some sort of suspension. Okay? And the other type of heterogeneous mixture is something called a colloid. It doesn't split into layers, and you don't necessarily able to tell the parts apart from each other. But here's some aloe gel. You put it on if you have a sunburn. It's, as you can see, it's really thick. All right, there's some air slowly going up. Okay, and as you read, there's another way that you can tell what's a suspension. And that's something called the Tyndall effect, the way it works with light. And I'm going to show you that. And that's why I needed everything to be dark. All right, so give me a second so I can go turn the light off, and we'll get back to that. Ooh, even more spooky now, right? Okay, well, here I have a flashlight. Okay, I'm gonna turn it on so you can see it's really a flashlight. There we go. See? I'm not gonna shine it right at the camera because it's way too bright. I'm gonna take this bottle that I showed you before, the green liquid. I'm gonna shine the flashlight through it. As you can see, it just kind of shoots right through. It doesn't spread out until it hits the other side of the bottle. That's because this is a solution, no Tyndall effect. I'm going to try it again with the aloe vera gel, which I told you was a colloid. Look, see how the light spreads out and makes the whole thing look glowing? The beam is not going straight through, it's spreading out. Much wider than the flashlight beam itself. Do it from the bottom, it really fills up the bottle. All right, that's the Tyndall effect. That's how I know this is a colloid, not a pure substance. Okay? All right, so that's it for today's chemistry lesson. Reach out to me if you need any further help with any questions, or if you'd like me to help you go over the reading passage, that would be fine. I can do that too. Just let me know. And I'll see you again in chemistry soon. Bye.